today we're doing 6-5 properties of special parallelograms. Okay, parallelogram has two sets of congruent sides, yes? Okay, and it has two sets of parallel sides, yes? All of the angles add up to be 360 interior, right? So there are things we already know about these that I'm not going to bring up, so don't forget them. Make sense?
Yes.
Okay, so let's go. You can do it. Okay, a rhombus. You have a picture. You will be adding to the picture after we do this. Okay. A rhombus, if a parallelogram is a rhombus, then the diagonals are perpendicular. I know, that is absolutely horrible.
It was beautiful. Oh, man.
No, it was not.
If I tell you so, you believe it eventually.
At least you would.
Perpendicular and bisect. The opposite angles. And all sides are congruent. But when we're solving the equation, yes, we set them equal. Okay, so on our picture, you see that the angles are bisected, yes?
Yeah.
See that? Yeah. Okay. I told you they are a parallelogram, and so all of these where the diagonals meet are 90 degrees. Yes. I didn't state that, but we should already know it.
Yes.
We know that these are all equal. Well, if it is a parallelogram, we know that this is equal to what? That one. And this one is equal to that one. Okay? So we already know those things, right?
Yeah.
So we can use it to find different parts. Okay, the next one, are we good? The next one we have is a rectangle. Again, there's obvious things I'm not going to state about a rectangle, but you should still know them. Okay, if a parallelogram is a rectangle, then the diagonals... That was interesting. I don't even know what happened.
Can I have an usher?
No.
Please?
No.
Please and thank you.
You need to show me.
Okay. If a parallelogram is a rectangle, then the diagonals are congruent.
Really? I wanted to say. You know, you're.
Okay, the diagonals are congruent. So that means, well, they also bisect each other, yes?
That means, hey.
So this is actually equal to this, which is equal to what? This and this. The one thing that I did not say and does not happen is they do not, they're not perpendicular. They do not meet. They're not perpendicular of each other. Okay? So we don't have that. But do we have 4 isosceles triangles?
Yes.
Yes. That we can use. We know that opposite sides are congruent. Yes. We know all 4 corners are what? 90 degrees. Okay. We know the sides are parallel. The tops are parallel. So we know a lot of stuff on there, right? Okay. Next, the last special one. And this is why they're special, guys. All rectangles are parallelograms, but are all parallelograms rectangles? No. All squares are rectangles, but are all rectangles squares?
No.
No.
That makes no sense.
Okay, so that's why these are special, because they all have their special. Okay, now a square, if a parallelogram is a square, the properties of both a rhombus and rectangle apply. So both things have to happen from a rhombus and a rectangle. So that was all the sides are congruent, right? The diagonals were congruent and they bisect each other. That's why the one line, correct? They intersect at what kind of angles? 90 degrees. I'm cutting, if this is 90, then this angle over here is cut.
That's supposed to be an E at the end of the rectangle.
Yes, I just quit writing.
Thank you, Miss.
Okay? So, if the applies, then this diagonal bisects this angle. Yes? So the whole thing's 90. Half of it is what? 45. So that means this is 45. That means this is 45. And 45, we could keep going all day, right? So there are things we know, and both apply for rhombus and rectangle to a square. So what we're going to do is use this stuff. You see why I said this is going to be quick today? Questions?
No.
Okay. What is the measure rhombus? And they have to tell you it's a rhombus unless they identify more stuff. Okay, what is the measure of RSP? So, RPS. RPS. So that's right here, yes?
Yeah.
Okay. But isn't that, well, what do we know?
They're not equal to 80.
Well, if 70 equals across from here, so SPR would be 70.
Mm-mm.
No,
S
angle
would be-
S would be 70.
Yeah.
You said SPR.
Yeah.
Uh-huh. Okay, so we know Q is 70, so does S have to be 70?
Yeah.
Yes. Okay.
I know how to get those.
What?
You subtract.
From what?
180.
and then
Because I have what kind of triangles?
And that's
Isosceles triangle.
And then you
So
divide it by 2.
180 minus 70
110.
is 110, and divided by 2 because this angle
5.
is the same as this.
Carry 1.
So it's what?
5. 55.
Okay. Have we done all this stuff before?
No.
Yay.
Yes.
Absolutely not.
Shut up, Cody.
Never. Okay.
Please stop. Cody, I'm asking you to stop, and you didn't need to respond. Okay, what is MNO? So MNO. So that's the big angle right here, the whole thing, yes?
Way.
Okay, so it is a rhombus, so I know what about all these sides?
They're all the same.
They're all the same.
So they would all equal 60.
So if I know this is 62, what do I know this one is?
62.
62. What do I know this is?
62.
Nope.
No,
90.
right?
90. So how am I going to find one of these?
So you add
62
them up
plus
and subtract
90,
them.
and then you minus that by 180.
Or could I just do 90 minus 62?
Yeah.
Why could I just do 90 minus 62?
90.
If one of the angles is already 90, right? What do these two angles have to add up to be?
180.
No, these two.
Oh, 90.
Okay, there's a lot of stuff. If this angle is 90, yes, what does this angle and this angle have to add up to?
180. No, 90.
90.
That's what I meant to say.
Okay.
That's what I'm trying to say.
Now, I could add 90 and 62 and subtract it from 180 if I wanted to, yes?
Yeah.
But could I also just subtract it from 90?
Yeah.
Yes.
28.
28.
Yes.
So here is 28, but I wanted the whole thing.
So 28 plus 28.
Okay, 28 times 2.
What is that?
Yeah, either one. Times 2 or 28 plus 28, right? I'd rather multiply than
56.
add. So it's 56 degrees. So again, guys, is this anything really new?
No.
No.
Yes.
Am I good?
No.
Yes.
91.
Let's go according to the top 16.
Okay. So, what are we going to do on this one?
You gotta find the triangle.
You have to solve for y.
We have to solve for y,
So,
and then we'll have to plug it in, right?
yeah.
So cute. Gosh, turn it. Okay, so QT is half, isn't it?
Yeah.
Half of this, isn't it?
Yeah.
Actually, we could divide by 2 or we could multiply by half, either one, right? Okay, so we know that QT is going to equal 1/2 of 5y minus 4.
Yeah.
So this is called critical thinking, guys. We're making a plan before we start, right? Randy said we have to solve for y. Yes. Why do we have to solve for y? So we can plug it into our equation we just made and we'll have our answer, right?
Yeah.
Okay. So now how are we going to solve for y? No.
Multiply 1/2 or
Well, no, we don't have, we can't,
5
okay, stop. We can't solve for y because in this equation we just wrote, because I have qt and I have y, I have 2 variables. I need to use something else first. Yes?
What would you do 3y minus 1 equals 2y plus 3?
I would definitely do that. These sides are congruent, so don't they equal?
yes.
Yes. Our problems, you should not be looking for the most part, our problems are not slapping your face right in front of you anymore, are they? You got to go find something. Are you guys finding it?
Yeah, I was trying to say you. What?
4.
I got these.
4, and then you're gonna.
Emma got 4. Anybody else?
Yes.
You're gonna plug it into the.
I get 2.
Oh, I did get 4. I lied.
Okay, so, and I have 4 equals 4 instead of y equals 4. So now I plug my 4 into where?
The
The-
equation.
Why?
Now, Brendan said I should distribute a half. I would totally distribute a half if I had a 6 there. I don't want to distribute a half to a 5. Why? It's not even, and then I'd have a fraction still, and I don't want to do that. So what's 4 times 5?
20.
20 minus 4,
16.
16. So half of 16 is
8.
8. So QT is
8.
8. Could I ask you for QS now?
Yeah, because they equal.
No, QS.
Oh, QS would be 16.
QS would be 16 because it would be the whole length, wouldn't it?
Yes.
Hey, so there's lots of questions I could ask. So don't just say, oh, there it is. But we made a plan and then we followed through how we were going to do it, didn't we?
Uh-huh.
Somewhat.
We good?
Yes.
So the next one are rectangles. Okay, so all the rectangle stuff. Find MP.
Well, which one isn't 5 on?
The 5 is right here.
Q.
Oops.
Wrong button. You said it.
No, I have to turn on the pin or it goes when it's right here.
Okay.
But it's a rectangle, so what do I know about all these pieces? So they're all.
Oh, no.
So what's MP? 10. So when I get a picture like this, I draw it. Guys, your art does not have to be beautiful. Draw the picture, label everything you know, and then should the problem be pretty easy. Okay, MQ.
What are you doing?
MQ.
Would it be?
Would it be 4?
No. It's a rectangle.
That'll be 8.
20.
Be 9.
Okay. Well, it's not any of those. Okay, we need to go over something that you've had to use in problems, but it hasn't. We're going to keep introducing it, and when we come back from break, we're going to do it all. What kind of a triangle did I just draw?
Right.
A right triangle, yes? Yes? So we have this thing called the Pythagorean theorem, and it is c squared equals a squared plus b squared. You have done it before, you've used it before, but I haven't made you just recall it any time. After semester, we're really going to hit it, and you will have to know it forever then. Okay, so A and B are just legs. So we'll just say this is A and this is B. Does that work?
Yeah.
C is always the hypotenuse. Remember, the hypotenuse is across from the right angle.
Yeah.
So this is C. Got it? So we're going to fill in the parts we know. What do we know C is?
10.
10. I know C is 10. I should not, I'm gonna write it up here. So c squared equals a squared plus b squared. Okay, so 10 squared equals, a is what? We don't know, do we?
No.
So a squared
Plus 4 squared.
plus 4 squared. Now, again, guys, a and b, it does not matter which one's which.
So 100 equals.
Okay? So now, this is 100, yes?
Yeah.
Equals a squared plus 16. Then I have to do what?
You
And we
gotta
have to
do it over
subtract this.
Subtract 16.
Yeah.
So 4,
84.
8, 84?
84, yeah.
Yeah? Okay, a squared.
And then you have to take the square root of
Then
it.
you have to take the square root because you got to get rid of a square, right?
Yes.
So square root and square root. Now, too bad that wasn't 64 because square root of 64 is what? 8. That is not a perfect square, is it?
No.
But we've got to figure out the ones in it. Okay?
4.
So a perfect square is like 4, 9, 16, right?
Yes.
I know 4 goes in 84. Anybody else?
Yeah.
Yeah. Okay. So we're gonna do a factor tree over here. Side note. So this is 4 times what? 21.
Yeah.
Are we good? 4 times 21.
Yes.
What times what's 21?
7 times.
7 times
40.
7 times
3. Are either one of those perfect squares?
No.
No. So do I need to break it down anymore?
No.
No. So what I have is the square root of 4 times 21. Well, what is the square root of 4?
7.
2. So I have 2 square root of 21 equals 8. Got it? That's the answer. So A, we said, was what? MQ?
Yeah.
So the answer is 2 square root of 21. Now, on your test, you will not have one that you have to remember. If you have to use it, I will say use a squared plus b squared equals c squared. Got it? But I probably won't put one on there. But can I find it that way?
Yes.
Yes.
You can put it as bonus.
Yep. But like I said, after Christmas, we're going to hit it hard. And we're going to learn it good. We're going to learn it good. Because you guys are amazing learners. Okay, square, last one. Okay, so it says, do you guys want to fill in stuff we know before we do the...
Yeah.
Okay, so fill in everything you know on that picture. Not out loud, just fill everything you know in on that picture. Angles, sides, everything.
What? Take the shirt off this week.
What?
That's weird. It's Christmas. You can't just
Yeah, just we're recording. No, we don't need to repeat that.
just stop talking.
Yeah, come on, man.
You're
Come back.
You guys done?
I think so.
I can't even get it.
Yeah.
I think so. I mean, you can write it down so I can double check.
No gravity.
Just release. Yeah? Is that all I know?
See.
I said, look what he did.
No, you know the outside.
Well, the outside's actually, is somebody figuring out the outside?
You have a right angle.
You have a right, give me, yeah. Because nope. We have a right angle here, yes? Gerhard.
The one across
Okay, this is C, correct?
Yeah.
So we have C squared equals 7 squared plus 7 squared, yes?
Yeah.
Well, what's 7 squared?
49.
49 plus 49 C squared. And then we're going to take the square root, right?
19.
So C equals, that would be 8,
Why won't you add them then do that?
9, because you have to, order of operations, like underneath a square root is considered a quantity. Is that what you're asking? You have to add them first.
Well, yeah, but I don't know if you had to add them, like, because you just wrote the square root over it, so I don't know if you're going to add them and then put the square
No, you have to. Okay, under a square root, there's like these imaginary parentheses, and I have to do parentheses first.
Okay, that's what I thought. I was
Okay, so I get what, 18 and 98?
Yeah.
And the square root of 98. Well, square root of 98 is not a perfect square, is it?
No.
Nope. What goes into 98?
It's 32.
13?
32.
Oh, 32. 32 times what? No. How about I know 2 goes into 98? How about you?
Yeah.
Okay.
Oh, but 32.
Now 4 doesn't go into it because 4 does not go into 98, so it doesn't go into it. So I'm not doing 4. So 2, and that would be what? 4, 9. Okay. Guys, didn't we just take 49 plus 49, which is 2 times 49?
Yes, and then it would equal C.
Okay, what's the square root of 49?
7.
7.
What's the square root of 2?
1.
No.
0.
No.
It doesn't have 1.
It doesn't have a perfect square. Thank you very much.
Yeah, you're welcome.
1.1.
So C equals 7 square root of 2.
It's like
That's
MC
literally
squared.
what we
That's a
have
ratio
up
or
there.
something.
No, it's not.
Wouldn't it be C squared?
No, because we took the square root.
How did you know that?
Okay, so we have all that, yes?
Yeah.
We don't need that, but awesome that you guys remembered that you could do it, and you did it. Okay, so we need angle. Oh, there's more that we know. Nobody else? Did you guys write anything else?
Yes, I did.
What did you write, Randy?
I said that all the sides are parallel. So I said
Okay, so they're all. Oh, so you put like this, and this,
yes.
and this, and this. And we can do this, this, and this. We don't have to keep writing 7 square root of 2, do we? What about this angle? What do we know this angle is right here? No, I know the whole angle, 45, right? So our,
You know what he said to me this month?
I want both of you to go sit in the hallway now. Okay, so all these angles are 45, yes? Okay, so now I think we have enough. So YPZ. YPZ. Oh, well, that's easy. What is it?
90.
90. Degrees. Don't forget your degree.
Then what was all that work for?
We're just knowing our knowledge to show how big brained we were.
There's 2 other questions
Okay.
you gotta answer.
XWP. So XWP is what? 45.
That's what I'm saying.
There were other questions answered. You were correct. XZ.
14.
XZ is 14 because it is 2 times 7.
Yep, we could just say that it wasn't.
Yes?
I have a question.
Yes.
How did you do that?
Yeah.
Because XZ is
Oh,
this.
never mind. I got it.
You good?
Yeah.
Wouldn't there be a degrees after 14?
Okay. No, 14 is a length, not a degree. Okay. Your homework is. It is on Classroom, but I'm going to write it up here because I should have written it on the board and I didn't.
4 from
Okay.
12.
No. Okay, your homework is page. Remember, you guys should be putting 6.5 on there. Page 284. 18 through 30. So, should that take you very long to do?
Yes.
No, because they're going to have a picture and they're going to ask you 3 questions about one picture.
Oh, that's simple.
Okay? Yes.
So
Oh.
page 284, 18.
Here,
I know, I've seen that.
I want you to have it. That's fine.